We are back. Previously, we were exploring the factors that influence the strength of a covalent bond. Factors that influence strength of a covalent bond. The session is suitable for students in A level, offering chemistry as part of their subject combinations. So previously, we had explored how atomic size influence the strength of a covalent bond. We said that if the sizes are big, then we have a longer bond. Sizes are big, when the sizes are big, we have a longer bond. And if the bond lengthens, if the bond is long, its strength decreases. However, if you have smaller sizes will form very short bonds with the increased strength. And I was giving an example of a jerry can. Hope that was taken into account. Then, which other property here? Then the other property is the bond length, the length of a bond. Now, this is what I've been explaining there up for atomic size. The length of a bond. If you have a longer bond, if you're having a longer bond and a shorter bond, this longer bond should be very weak. Why? The bond which is long offers a larger surface area towards its breaking. Therefore, one can easily break it. And I gave an example of a jerry can. Then a bond which is short, it's like it is compacted to expose it, to tear it up, requires large amounts of heat energy. Therefore, a bond which is short is strong. Bond which is short is strong. So what are we saying here? The strength of a covalent bond is inversely proportional to bond lengths between bonding atoms, meaning that if it is inversely proportional, increased or greater strength is for greater strength, and we are saying it is inversely proportional. So greater strength or high strength should be for smaller length. The greater or stronger or higher strength should be for small bond length. Then, on the other hand, weaker strength or lower strength, weaker strength or lower strength should be for a longer bond. Why? The longer, we are saying that the longer the bond, the longer the bond length, the weaker the bond strength. It is what I've been saying here. If you're having a bond which is long, it is exposed. A bond which is exposed is weak. You can easily break it. It's like you have very many points of hitting it as compared to that one which is short. And the shorter the bond length, the greater the bond strength. Why? Why are we saying that? If you are having a shorter distance between atoms allows for greater orbital overlap, resulting in stronger attraction and increased bond length. What does this mean? A shorter distance like the one here, if you are having a shorter distance will mean that these atoms, for example, if it is between atom A and the atom B, these atoms are very close to each other. If the bond is short, it's like the orbitals within these atoms are close to each other. And that allows for greater orbital mixing. Their orbitals is like they are mixing together. The orbitals of A and the orbitals of B are very close to each other. Therefore, they end up mixing so that it's like you almost have no space of separating them as compared to when the distance is long. That's why here we are saying that a longer distance between atoms allows for weaker mixing. So the mixing is there, but the atoms are not so much close to each other. Therefore, that should result in weaker attraction and decrease the bond strength. So that is bond length. What is the key takeaway? This is the key takeaway. Colleagues, recall that I said this in class, and I'm going to repeat it here on MWES. No one is going to ask you to explain these factors. No one. However, we use these factors to explain. For example, you will be given a substance A and a substance B. Can you link this knowledge and use it in comparing substances? Otherwise, you are not going to encounter a scenario where you are tasked to explain how these factors influence the strength of a bond. No. So we shall look at those applications at a later stage. But you get the key takeaways. You may not understand everything, but if a bond is long, these atoms are not close to each other. They can be separated. It's like they are spaced. If a bond is long, the atoms are spaced. So therefore, you have very many ways of hitting that bond. Therefore, that bond should be weak. Then, if a bond is short, the atoms are so close to each other. Therefore, we have strong attraction. Same thing applies for atomic size. If you are big, you closely approach each other at a low rate. If you are big, you move slowly. Therefore, that will be a longer bond, which is weak. Then if you are smaller, you easily move quickly so that the bond becomes short and strong. Colleagues, allow me. I don't know why. I think my screen has jammed. Oh, it is here. I thought that it had frozen. You know, this technology is a bit stubborn. Then we look at another factor. What does this factor say? Now, this factor is on number of bonding electron pairs. You recall the electron pairs? I highlighted these electron pairs at school and what they mean. I highlighted them and I said that for a single bond, recall for a single bond, formation of a single covalent bond in chlorine molecule. That example, single covalent bond in chlorine molecule. Chlorine contributes 1 electron and another chlorine contributes 1 electron. That's one pair. You also recall formation of what? Formation of oxygen molecule. Oxygen molecule has a double covalent bond where one oxygen brings 2 electrons and another oxygen brings 2 electrons. Therefore, here you have, for a one line, you have one pair of electrons, one pair of bonding electrons. Then, for the double lines, you have 2 pairs. You have 2 pairs of bonding electrons. 2 pairs of bonding electrons, those are 4 electrons because one pair has 2 electrons. Then if you have 3 lines, these are 3 pairs of bonding electrons. 3 pairs of bonding electrons, you have what? For 3 pairs of bonding electrons, you have 6 electrons. There are 6 electrons. So I want to write this right. I want to write these cases in this form. This is single. That is single. Then this is double. This is double. Then this is triple. Like that. Now you see, what am I trying to say? I'm trying to say that the one that is one pair is long. 2 pairs, the size reduces. You see, this one here is long. 2 pairs, the size reduces, and 3 pairs, it reduces further. Now, you also think about this. If you have very many electrons, because for 3 pairs, think about this very well. For 3 pairs, you have very many electrons there. You have a huge electron density. Here you have too much electrons density. There is a very strong density. You know what that implies? That bond will be strong. Where you have too much electrons as compared to this one where you have 2 electrons, and where you have, as compared to this where you have 2 pairs, and as compared to this where you have 1 pair. This is something which you can relate to. If you have too much electrons, there must be increased strength. If the electrons are few, you have decreased strength. Therefore, a single bond is weaker. A single bond is weaker as compared to a double bond and a triple bond. Moreover, a triple bond is strongest. A triple bond is strongest as compared to the double and the single. So what are we saying here? The strength of a covalent bond is directed to the number of bonding electron pairs between bonding atoms. Is directly, now this is directly. Why? You have increased strength if you have many bonding pairs of electrons. I have been highlighting that for the triple bond. The strength is high if the electrons are many, or if the electrons are also high. Increase in electrons increases strength. Decrease in electrons decreases the strength, like that. The lower, you see, here I'm saying, the lower the number of bonding electron pairs, the longer the bond length and the weaker the bond strength. The one for the single covalent bond where we have 1 pair. If you have 1 pair, what do you have? The lower the number, like 1 pair, the bond is long and it is weaker. The higher the number, 3 pairs, too much electron density, that bond will be shorter and greater. Moreover, I emphasize it here, colleagues. Triple covalent bonds, which involve 3 electron pairs, are shorter, stronger than double bonds, which involve 2 electron pairs, which are also shorter and stronger than single bonds that involve 1 electron pair between similar atoms. So that is the effect of bonding electron pairs. So let me first stop this here.